carefully. A prism it says three-dimensional figures. You have each flat surface is called a face. The edge is a segment where two faces intersect. The vertex is a point where three or more faces intersect in a cone. It is where the curved surface comes to a point. So this is one vertex, 2, 3, 4, 5, 6, 7, 8. So it's 8 vertices. Now prisms. The prism is called by the name of the base. Okay, so this right here is a square. It could be a square, so this is a square prism. If this is a rectangle, then it's a rectangular prism. So the faces are parallel to each other. Okay, now this one over here is supposed to be a triangle and a triangle. So these two faces are triangles, so therefore it's called a triangular prism. And notice that on the prism, all the lateral faces, lateral means the round, all those lateral faces are rectangles. While in the prism, all the lateral faces are, what shape are those? Triangles, that's right. Okay, so in pyramids, the lateral faces are triangles. And the pyramid is named by the base, the name of the base. So this is a triangle, so therefore it's a triangular pyramid. This is a rectangle, so therefore it's a rectangular pyramid. Okay. Now something that we need to keep in mind is that in circular shapes, like in the cylinder base, it's a circle, and so is the base of a cone. It's a circle. Neither the cylinders nor the cones have edges, because in order for you to have edges, you have to have polyhedrons. Okay, so poly means sides, and for sides need to be flat surfaces. These over here are kind of like curvy surfaces. That's why it's not a polygon or a polyhedron. Okay, so let's answer these questions. Number 1, it says classify the figure. So what's the name of that figure? And it's hard to see, but it's supposed to be like this. It's a triangular pyramid. That is right. So this is a triangular pyramid. So that's the name. Now, how many, it says name the vertices. We're not going to name the vertices, okay? So we're just going to put the number of vertices. So how many vertices do we have here? We have 4. That is right. We have 4. So this is 1, 2, 3, and 4. So it's 4. How many edges? So edges is 6. See, we have 3 in the bottom, and then 3 going up, 4, 5, and 6. So it's 6. And how about the base? Base is only 1, right? It's only one base. And what is the name of the base, if that was to be asked was? It's a triangle. And this is triangle what? You name it by the 3 letters. Q, this is S, and that is T. Yes, so it's Q, S, T. You can also use the notation triangle, Q, S, T, if you want to do that. Okay. Any questions about example 1? So we're just naming the parts of a solid. Okay. So now let's move this out of the way. Let's focus on number 2. So for number 2, what is the name of that figure? It's a cylinder. Okay, it's a cylinder. And I need to get the vertices, the edges, and the bases. So, any vertices? If you look at the top, it says cylinders and cones don't have vertices, right? So it's none. How about edges? None. How about base or bases? You have 2 bases. And can you see the letters? What letter is this one? A and B, okay, so if that is the A and this is the B, we can say that is circle A and circle B. And those are the names. You can mention the word circle if you want to, okay? Any questions on mentioning the parts of the solids? So far so good? Okay. Now let's go ahead and move on to number 3. So in number 3, we're going to do the same thing. Okay, so what is the name of that solid? It's a triangular prism, yes. And then we need to get the vertices, the edges, and the faces. Vertices, how many vertices? 6. We have 6, that is right. There's 1, 2, 3, and then 3 on the back, so it's 6. How many edges? It's 9. It's 3 in each one of the bases. This is 3, another 3, and then 7, 8, and 9. So it's 9 edges. How about faces? 5 faces. It's 3 lateral faces, right? Around is 3, and then the 2 bases, that would be 5. That's it. Great. Now for number 4, what's the name of that figure? It's a cone. Is it just a cone? How about vertices? Okay, so it's vertices, edges, and faces. How many vertices does it have? It's only 1. Which is that 1? It's just a point M, if you were wondering what was that, okay? How about the edges? None, because edges are segments where 2 faces get together, okay? And this is a curvy area, it's not a flat, you know. So what about the faces? 1. It's only 1. Which is that face that you were talking about? The circle, whatever that letter is, L, that is right. Circle L, and that's it. Okay, so this part is just talking about the parts of the solids. Any questions about how to determine the parts of the solids? No? Okay, now, the second part, which is on the right side, the cross section. You have eaten a lot of cross sections, right, in your life. This is a cross section. See, it's a triangle. This is like this. It looks like this. It looks like this. And then this is like the knife that is cutting. Okay. That figure. So if we were to cut it, what's going to be the shape? Well, the shape is going to be this piece. Okay. So it's like if you have maybe, I don't know if there's some, what is it that could be like a triangle? Cheese, can cheese come in a bar of triangular prism? Could be, right? Yes. So when you cut that cheese or the loaf of bread, when you get a slice of loaf of bread, that is a cross section. And what is the shape of that cross section that you get to make your sandwich? What is the shape of that? The same of the bases is just a piece of it, right? Well, that's a cross section, okay? So a cross section is when you get the loaf of bread and you get a slice, that is a cross section, okay? Now, I usually cut the cakes, when they're circular cakes, I cut them in like rectangles. So how do I cut the cake? Let's go ahead and talk about number 5. Describe the 3-dimensional figure that can be made from the given net. What would be the shape of the, well, what would be the name of the 3-sided figure for number 5 when you fold that net?
Rectangular prism.
It's a rectangular prism. What about for number 6? It's a triangular what? pyramid. That's right. Everything except for the semicircle. Okay, so then one thing that I want you to